Hello students. Now we are going to start with our next model question paper, that is model question paper 2 for the year 2025-26. So subject science, you can see here the time given for this paper is 3 hours 15 minutes. The maximum marks are 80. And as we all know, this paper consists of three parts: part A physics, part B chemistry, and part C is biology. Here I have wrote what is the total marks given for each part. So as you can see here, for part A physics, the total marks is 27 out of this 80. For part B, that is chemistry, total marks it is 25 out of 80, and part C biology has got 28 marks out of 80. So here as we can see, biology part has got maximum marks out of this total 80 marks. So this will be same for all the question papers, even for your final exam. So now we are going to start with model question paper 2. So let's move with the first question. So now we are going to start with part A, and that is nothing but physics. So here question number, as we all know, it is multiple choice question. So we'll start with this one. So that is four alternatives are given for each of the following questions or incomplete sentence. Choose the correct alternative and write complete answer along with its letter of alphabet. So here you have to focus students. You have to write the complete answer along with its alphabet. So A, B, C, which option is correct? That A, B, C, that alphabet you have to write, and with that you have to write your complete answer. Some students will write only the alphabet. Some students will write only the answer. But remember this, whenever you start solving the question paper, first read the question, see what they have asked, and then start writing. So now we will start with question number 1. The SI unit of electric current is. So we have to write the SI unit of electric current. So here we have four options. Option A, ampere. Option B, ohm. Option C, volt. And option D, it is watt. So if you see these all the options, in these all, here the option A, that is ampere, is the correct answer. This is the unit which is used to measure electric current. If you ask about option B or the other options, option B, ohm, it is the unit of resistance. Volt, option C, that is, it is the unit of voltage. And option D, watt, it is the unit of power. So in our question, they have asked electric current, and therefore the correct answer is option A, ampere. So as they have told, I have written here option A, and the answer is ampere. So remember this, like this only you have to write your answer. You have to write alphabet and you have to write complete answer. So this was question 1. Now we are going to move with question 2. Question number 2. Observe the figure given below. The magnetic field at the center C of a circular coil is. So here this diagram has been given. You have to see this figure and you have to tell what will be the magnetic field at this point, that is center C. If you focus this diagram, this is the A point of this wire. This is the B point of this wire. First this wire is straight and then it has converted into a coil like this, and then it is moving straight. So once the current I enters from this A to this circular coil, it divides into two like this. And as we know, when the current enters into the wire, it generates magnetic field around it. I hope you remember this. Whenever the current is moving in a straight conductor, it generates a magnetic field around it. That is nothing but our one of the law, and the law is called right hand thumb rule. What the law says, whenever we hold a current carrying conductor, a straight current carrying conductor in our right hand, then if the thumb is pointing the direction of current, then the finger wrapped around it will point the direction of the magnetic field lines which are generated around the conductor. For example, if this is the straight conductor and if this is the direction of the current moving in this straight conductor, then the fingers wrapped around it will give the direction of the magnetic field line. The straight same conductor, if we bent it and convert it in a coil, for example, imagine if this is the straight conductor which we have bent and converted into the coil, and now suppose this is the direction of the current is moving in this coiled wire and then it is coming back like this, then if we hold here our thumb pointing upward, and if these are the fingers wrapped around this wire, along these fingers the magnetic field lines will be developed, and those magnetic field lines will be like this. So these are magnetic field lines. In the same way, if we hold our thumb in the reverse form, on this direction here, if this is the thumb pointing the direction of the current which is going downwards, then the fingers wrapped around it will show the direction of the magnetic field, and here also we will get the magnetic field lines like this. So if you focus on this diagram and the question which is asked in the exam, it looks same. So once the current enters in a straight conductor and once it divides into the circle, the current when it is moving in this direction, the circles will be formed here. And on the same way, when the current is moving in this direction, again the circles will be in the same direction. And when the circles will increase at the center, when those both the circles, concentric circles will join, and here they will form a straight line. For example, in this diagram, if you see, as these concentric circles will increase like this, here also we will increase like this, and when these concentric circles both will join at the center, here it will become a straight line. At the center it will become a straight line, and the magnetic field will get cancelled, and here it will give 0 as magnetic field. In the same way, even in this diagram, these concentric circles which are formed here and at the same time the concentric circles which are formed at the bottom, all will join at the center, and at point C we will get a straight line for this magnetic field line. And whenever we will get a straight line, the magnetic field will be 0, and therefore the option will be 0. First we will see the options. Option A is 0, option B is 1, it's I, option C is I2, and option D is 2I2. So here the correct answer is option A, 0. I will read the answer. At every point of an electric current carrying circular loop, the concentric circles representing the magnetic field around it would become larger. So as I told, whenever the current is moving in a conductor, for every point, at every point there will be the formation of concentric circles like this, and these circles will increase in the size. They become larger and larger as we move away from the wire. So this is the wire. If we move away from the wire, the circles will become larger. By the time we reach at the center of the circular loop, the arc of these big circles would appear as a straight line. So at the center, here it will be a small circle, then the big circle, and when we reach at the center, here it appears a straight line. Every point on the wire carrying current would give rise to the magnetic field appearing as straight line at the center of the loop, and therefore the option is A, 0. So when these concentric circles on this line and the concentric circles on this line joins here, it will be a circle. If we focus here at this point, here also there will be concentric circle, and here also there will be concentric circles. When these will come and join at the center, here it will be straight line. So at every point on this circle, there will be many concentric circles, and when these all circles will come to the center, they will form a straight line, and therefore the answer for this question will be 0. So we should write option A, 0. I hope you understood the explanation of this question. We have to think a little bit in a different way, we will get the answer. By seeing this figure, you should not get scared. It is very easy. Just think once and write down the answer. Now, section 2, that is answer the following question. This section carries total 2 marks. So question number 3, which mirror is used as rear view mirror? The mirror which is used in our vehicles. So here we have to tell which mirror is used in vehicles, and the answer is convex mirror. We have 2 types of mirrors, concave mirror and convex mirror. Also we have one more type, that is plane mirror. Out of these all the mirror, convex mirror we are using in vehicles, and the reason for this is convex mirror always give erect and diminished image, as well as it will cover a wider area, and that's why the driver will be unable to view much larger area than would be possible with a plane mirror. So instead of plane mirror, in plane mirror we can see a very small area, but in convex mirror we will see a wider area. It will help the driver to drive properly or to get the idea about the beside vehicles, and that's why we will use convex mirror. Now the next question, question number 4. List any 2 suggestions to avoid the overload in domestic electric current. So to avoid the overload in domestic electric current, what we can do or what we can suggest. So the first one is using fuse. So fuse, if you use in our electric current, it has one alloy, and whenever there will be a high voltage, this alloy will melt, and because of that process, the electric current or the movement of current will be avoided or prevented, and due to which all the appliances in the circuit will be safe. So this is one suggestion. Second, avoid connecting too many appliances to a single socket. So there will be many sockets in our house, but what we people will do, we will use many appliances in a single socket. In the same socket, we will keep our mobile for charging. In the same socket, we will use sometimes mixer or the iron, etc. So we should not do that. If we avoid connecting many appliances in a single socket, then also we can avoid overloading in our electric current. So these are the two suggestions we can write for this question. Now we'll move to the next question. Now the next section, that is section 3, answer the following question. Here this section carries 6 marks. Question number 5, draw a simple circuit, label ammeter and voltmeter. So we have to draw a simple circuit. So this is a simple circuit diagram. Simple circuit means what? It should have a battery, it should have a switch, it should have ammeter and a voltmeter. It is called a simple circuit. So after drawing that simple circuit, we have to label ammeter and voltmeter. So if you see this battery, it will be having one side positive end, one side negative end. Then from positive to negative, we have to put some arrows. These arrows will indicate the direction of electric current. Then here this is the ammeter. We have to label it. Always ammeter will be connected in series with the battery. And this is voltmeter, which will be connected parallel into the circuit. Always the positive end of the voltmeter and the positive end of the ammeter should be towards the positive end of the battery. Negative end of the voltmeter, negative end of the ammeter should be towards the negative end of the battery. So this is called the simple electric circuit. So here in this question, it is asked ammeter and voltmeter to label. In some other question, they may ask something else like battery or switch. So you should remember the labeling, all the labeling which are present in this diagram. Now we'll move to the next question, that is question number 6. An electric motor receives 10 ampere electric current. So this is electric current from 220 volt electric source. So this is 220 volt. Find the power of motor. So here we have to find power. So after reading the question, first understand what is given in the question and what we have to find out. And once we understand what is given, then first write down given all the values and then you think about the formula which we can use. So we will write first all the given things. So what is given here? So write down first answer. So we have current, here it is given 10 ampere, electric current symbol is I. So I is equals to 10 ampere. Now again what we have here voltage, that is 220 volt. So voltage symbol is V. So therefore V is equals to 220 volt. What we have to find out? We have to find out power. Power symbol is P. So P is equals to question mark. This we have to find out. Now think about the formula in which these all the terms should come: current, voltage and power. So the formula used in this question is power is equals to voltage into current. So we will write it here. Power, that is P, is equals to voltage into current. So this is our formula. So write down formula and now we can substitute all our values. So write down P is equals to, what is our voltage? Voltage is 220 and our current is 10. So when we multiply this, we will get the answer 2200. And here we have to write the unit of power. So the unit of power is watt, which is denoted by the letter W, capital W. So don't forget to write the unit. Whenever you solve the numerical, always remember you have to write the answer into the box and you have to write the unit. So this is the neat way to solve any sum, because there will be marks for this unit, what I am writing here, watt. So always remember to writing unit for the given value. So this is the answer for question number 6. Now we'll move to the next. Now question number 7. Draw a diagram of experiment conducted by Newton to show the recombination of white light. So here we have to draw the diagram of recombination of white light. So this is the diagram which is given in your textbook also. So what we have to do? We have to take here two prism. This is first prism. This is second prism. Second prism is inverted. So you can see here it is inverted. And from here the white light will be incident on this first prism. This is a narrow slit from where the white light is incident. So when the white light hits the first prism, at the boundary of this prism, at this interface, refraction takes place and this white light splits into 7 colors. That is Vibgyor. We know this Vibgyor. So like this, the white light will split. and these all 7 colors will travel in this first prism, and when they comes to the boundary of this prism, so see this is another interface of this prism. From here they will come out. So this is the light which is coming out. So in Vibgyor there will be violet and other side there will be red. In Vibgyor, V means violet, R means red. So this is violet color, this is red color. These all 7 color, now we are going to pass from the another prism. But the second prism, if you see, it is inverted. When these 7 colors hit this second prism, here again there will be refraction. So you can see the bending of light. This is the bending. Again this is the bending. So when these all the light rays, this colored all the light rays enters into the second prism, at the boundary here again there will be refraction, and these all light rays will travel from this second prism, and once they come out, all the 7 color will recombine and comes out as again white light. And here there is a screen which will record that white light. So why it is called recombination? First it was a white light split into 7 colors. These all 7 colors will again combine together and again it comes out as a white light. So it is called recombination of white light. So this is a diagram of recombination of white light. And here the question is draw a diagram. They have not asked anything for labeling. But why I have labeled in this diagram? Because maybe in other exam if they ask label prisms or label white light or label 7 colors, so you should remember. So this is just for practice, and therefore whenever we practice we should write all the labelings which are present into the diagram. But in exam whatever they have asked to label, only that much we can label. So this is the answer for question number 7. Now we are going to move with our next question. So now the next, that is section 4, answer the following question, and this section carries total 9 marks. We will start with the question number 8, which has A and B section. So we will see first A, that is state 2 laws of reflection of light. So here we have to write the 2 laws of reflection. So answer, first one, answer the angle of incidence is equal to the angle of reflection. So as we know, in case of reflection there will be 2 angles. One angle is called incidence angle, which is the angle between incident ray and normal, and the second angle is reflected angle, that is the angle between the reflected ray and the normal. This we can easily understand with the help of diagram. So I am going to draw the diagram for this explanation. So this is the diagram actually of reflection of light. No need to draw this diagram for this question, just for explaining this 2 law I have drawn the diagram. So here this is the surface where light is going to incidence. So if this is a incident ray, so the light ray, it is called incident ray. So this ray of a light comes and hit this surface here. The point where the light will hit, we will draw a perpendicular line, and that is called as normal. So this is normal. This is our incident ray. I will make this I capital. This is our normal, and after hitting at this point, the light will get reflected back into the same media. So this is a reflected ray. See the arrows. This arrow indicates it is going back. So this is called reflected ray. So I will write it here. Reflected ray. So this is reflected ray. Now with the help of this diagram, we will understand our laws. So what is the first law? So if we see the first law, it says angle of incidence is equal to the angle of reflection. So where is angle of incidence? The angle between this incident ray and this normal. So this is the angle. This angle is called as incidence angle or angle of incident. We will label it. So here I have labeled I. I means angle of incidence. Then this is R. What is R? The angle between a normal and reflected ray. So that is angle of reflection. So this both the angle will be always equal in case of reflection of light. If this is at 30 degree, then this will be also 30 degree. Imagine if the incident ray is coming like this, then the angle of incidence increases. Then the angle of reflection also will increase. So it will be like this. If again the incident ray, imagine if we draw here, then the reflected ray will be here. So you can understand now, if the angle of incident changes, angle of reflection also changes, and always they will be equal. So this is the first law. What is the second law? The incident ray means this one, and the normal to the mirror at the point of incidence. Normal means this one. This is called normal, which is present at the point of incidence. And the reflected ray means this ray. All lie in the same plane. So this is the plane. This is the plane. Paper or the screen, it is the plane. So this all the 3 rays, that is incident ray, normal and reflected ray all will lie in this plane itself. Means no ray will come out of the screen or above the screen, and that is only our second law. So once again I will read. The first law is angle of incident is equal to the angle of reflection. Second one, incident ray, the normal to the mirror at the point of incident and the reflected ray all lie in the same plane. So this is the answer for question number 8A. Remember students, no need to draw this diagram. This I have drawn just to explain you people. For this question you have to just write these two statements. Now we will move with question B. What is magnification of mirror? What does the negative sign indicates in the magnification value? So the answer is, what is magnification? First we will write that. So magnify means making it big, making something big is called as magnify. So we will write, it is expressed as the ratio of height of image to the height of object. So always remember, if we want to find out how much our image has got big, then we have to find out the ratio. And ratio of what? The ratio of first height of image and then the height of object. It is usually represented by the letter m. So small m, it is used for magnification. If h is the height of the object and h dash is the height of the image, then the magnification by a spherical mirror is given as. So according to this formula, what we have to do? We have to divide height of the image by height of the object. Therefore, small m is equals to height of the image, that is h dash, height of the object, that is h. So this is the formula of magnification and this is the definition. Now again this question has one more part. What does the negative sign indicates? So this m value, whatever we will get, it may be positive or it may be negative. So if the value is negative, then it indicates that the image is real, which is very, very important. You have to remember this, because this will help you sometimes in numericals, problem solving. Sometimes it will be asked. After finding out the magnification, depending on the magnification sign, you have to tell the image is real or virtual or which type of mirror is used. So these type of questions will come. So this will be the hint to remember. So if m value is negative, then our image will be always, it will be real. So remember, if m value is positive, then it indicates that the image is virtual. So these are the 2 points which you have to remember. In this question, they have asked about only negative. So only the first point is enough. But I have given the second point also, because this is we are using just for practice. So remember these all the points whenever you write or whenever you prepare for your final exam. Now I will move with the next question. So now we are going to solve the OR question from this 8th question, because here we have choice. Either you can solve first A and B, or we can solve this OR question. So the question is, explain the activity which shows the refraction of light through glass slab. So we have to explain the whole activity which shows the refraction of light through this glass slab. So here, this is the diagram which we have to draw for this question. Remember, diagram is compulsory for this question. We have to explain the activity, means we have to draw the diagram. So this is the diagram. First we will see the construction and then we will see the activity. So what we are going to do here, the first point, fix a sheet of white paper on a drawing board using drawing pins. So we are going to take one white board like this, white sheet, and on this we are going to fix this with the pin. Then place a rectangular slab over the sheet in the middle. So this is the glass slab which we have kept it in the middle on that paper. Draw the outline of the slab with the pencil. Let us name the outline ABCD. So exactly beside this glass slab we are going to draw one outline like this, rectangular shape, and we have to label A, B, this is C, and this is here D. Take 4 identical pins. We are going to take 4 identical pins. Fix 2 pins, say E, F, vertically, such that the line joining the pins is inclined to the edge AB. So we are going to fix one pin here, which is vertically to the surface, and we are going to fix it in such a way that the line, if you join these two, it should be inclined like this and it should fall on this AB surface. Remember, it should not be straight like this. It should be inclined like this. So this is E and this is F. And the line, if you join, it will be inclined and it should fall on what? This surface, that is called as AB interface. Next, look for the images of the pins E and F through the opposite edge. So you look from the opposite edge where the image of E and where the image of F will form. Next, fix 2 other pins, say G and H, such that these pins and the image of E and F lie on a straight line. So take another 2 pins, G and H and fix it in a such a way that these E, F and G, H both should lie on the same line. Like this you should draw it. So here, if this is here E and H, then here I have fixed this G and H. Now, next, remove the pins and the glass slab. Now remove everything. Remove this E, F, G, H pin, even remove this glass slab and join the positions of the tip of the pins E, F and produce the lines up to AB. Now wherever there is a E, wherever there is a F point, join this line and extend it till AB. Let EF meet AB at O. So this EF will meet at O. So this is the point where it comes and meet at AB. Similarly, join the positions of the tip GH. So we have joined even GH and we have extended it until CD, which will join at O dash. Join O and O dash. So this is O and this is O dash. Now we will join this also. Also, produce EF up to P as shown by the dotted line. So this is EF hits at O, and from here you have to draw this dotted line parallel till P. So this is the construction. So what we did here, once again I will explain fast. So we took one paper, white paper. On that white paper, at the center we placed one glass slab. We have drawn the boundary of this glass slab, labeled A, B, C, D. Then we took 4 pins, same 4 pins. One we placed at E, one we placed at F, but we have placed in such a way that if you join, the line should be inclined and we should hit at O on this AB. From the opposite side, we try to saw the images of those E and F and we got the images at G and H. Then, after doing this all, remove pins and glass slab and join all the points. Join E and F till AB, and on AB it will join at O dash, sorry, O. Join G and H till CD, you extend it. On CD it will join or hits at O dash. Now, join O and O dash, the line which is present inside the glass slab. So that is O and O dash, also join it. And now extend this EF with the dotted pattern till P. So this was the construction. Now we will see why these all bending takes place. Now we will see the explanation of this whole activity. In this activity, you will note that the light ray has changed its direction at point O and O dash. So see this light ray which is coming straight. Once it reaches at O, it bends like this. So if you focus, here it is straight and it has bent like this. Now, even if you focus at O dash, when the line comes straight like this, once it hit here, it goes like this. So see a little bit of bending. So at O dash also it is bending, and even at O also it is bending. Next. Note that both the points O and O dash lie on surfaces separating two transparent media. Now see O. O is present on the surface which is separating this air media and this glass media. Even O dash, if you see, this is also present on the surface which is separating this glass media and this outside is air media. Draw a perpendicular line, that is N dash, to AB at O and another perpendicular M dash to CD at O. Now wherever it has changed the direction, that is point O and the point O dash, we will draw a perpendicular line. So this is one perpendicular line on AB, this is another perpendicular line on CD. The light ray at O has entered from rarer medium to denser medium. So if you focus at O, the light ray is coming from air and entering through glass. So it is rarer media and this is our denser media. So light ray is entering from rarer to denser media, that is from air to glass. Note that the light ray has bent towards the normal. So if you see, this is our normal. The light ray, instead of going straight, it is bending towards, it is coming towards the normal. Now, when it will bend towards the normal, when the light ray entering from air to glass. Now, we will see the next. At O dash, the light ray has entered from glass to air, that is from denser medium to rarer medium. So see that. Now see here for O dash, the light ray is coming from the glass media, that is denser media, and entering into the air media, it is bending away from the normal. This is towards the normal, and here if you focus, it is coming straight and it is going like this. So it is going away from the normal. So remember, at O it is bending towards the normal and at O dash it is bending away from the normal. Remember this. When it bends towards the normal, when the light enters from rare media to glass media, and when the light will enter from away from the normal, when the light enters from denser media to rarer media. Now the next, now we will see the next, that is the light here has bent away from the normal. So this is in case of O dash point. Compare the angle of incidence with the angle of refraction at both the refracting surfaces AB and CD. Now see the angle of refraction. This is called as angle of refraction here, and here this is called as angle of refraction. Here it is I1 angle of incidence, R1 angle of refraction. This is I2 angle of incident 2. This is R2 angle of refraction 2. So this angle is small because it is bending towards the normal. This angle is big because it is bending away from the normal. So this value of this angle we have to compare. It is bending towards, it is bending away. These bending, if you compare, then we will understand how much is the bending of this light ray exactly compared to the starting our incident ray, that is EF. Now we'll move with the next. See here, compare the angle of incidence with the angle of refraction at both the refracting surfaces AB and CD. In diagram, ray EO is obliquely incident on the surface AB. So this EO light is obliquely incident on the surface AB, then called incident ray. This is incident ray, correct. This is the incident ray. O dash is the refracted ray. So after refraction, this is the refracted ray. And when the light comes out of this glass slab, this is called as emergent ray. So this is O dash and this is H. So this is called as our emergent ray. What is emergent ray? The ray which is emerging out, coming out, that is emergent ray. You may observe that emergent ray is parallel to the direction of incident ray. So if you draw this perpendicular, here we have drawn this dotted line straight way. This is extended. So this is our incident light, and after emerging, this is our emergent. So if you see emergent light and this incident light, both are parallel to each other. So parallel to the direction of incident ray. The extent of bending of ray of light at both opposite parallel surface AB and CD of the rectangular glass is equal and opposite. The extent of bending, how much it has bent towards the normal, that much it has bent away from the normal. So this bending, if you see, it is equal but it is opposite. The value is equal. How much it has bent towards the normal, same amount it has bent away. So value is equal but the direction is opposite. Now we will see, this is why the ray emerges parallel to the incident ray, and that is why the emergent ray and the incident ray both are parallel to each other. So remember, from this experiment what we will understand? We understand that if we change the media, the extent of bending also changes. In rare media, the line comes straight. When it hits and enters into the denser media, the light ray bent towards the normal. In denser media, why it is bending towards the normal? Because in denser media, the speed of the light decreases. It will not cover the more distance like this. It covers the less distance, and to cover the less distance, it will bend towards the normal. But when the light enters from denser to rarer, this is rarer media. In rare media, speed of the light will be more. So once it enters into the rare media, it tried to cover the more distance like this. Instead of covering the less distance, it tried to cover the more distance. And that is why this bending takes place. And that is only the same thing only explained by this activity. I hope you understood whole activity which I have explained in a simple way. So this was our OR question from the question number 8. So now we'll move with question number 9, which has again a OR question. First we will see this A and B. So question number A, what is nearsightedness, or it is also called as myopia or myopic eye? So nearsightedness or myopic eye means the person can see nearby objects clearly but cannot see far objects clearly. So I hope you understood this question. There are two diseases, nearsightedness, that is myopia, and farsightedness, that is hypermetropia. So here in myopia, nearby objects can be seen very clearly, but far objects will not be seen clearly. And opposite to this will be a hypermetropia. So remember both the disease. Sometimes hypermetropia also will be asked. Now question B, what is power of accommodation of eye? How does the eye accommodate to see distant objects? So here first we will write what is power of accommodation of eye. The power of accommodation of eye is the ability of the eye to change the focal length of its lens so that objects at different distances can be seen clearly on the retina. We have to see the objects were present at far distance as well as on the nearby distance. according to the distance, I will adjust the focal length of our lens, the lens which is present in our eye. And by adjusting the focal length, adjusting means what? Focal length increases, sometimes focal length decreases. And because of this adjustment, we can see the objects present on different distances clearly. This is the first answer. Now the question is, how does the eye accommodate to see distant objects? Here I have given both the object present on distance as well as nearby. According to question, you have to write the answer. So see here, when we look at distant objects, whenever we look at the objects the present on the far distance, ciliary muscles relax, eye lens becomes thin and focal length increases. Remember, if you want to see the objects present on far distance clearly, then focal length should increase. And to increase the focal length, how eye will accommodate? Ciliary muscles will relax and eye lens becomes thin. So till here, it was the answer for this question. This point 3, which is I have given extra, we should remember because this is just for practice. So remember everything. We don't know which question is going to come in the exam. So always prepare thoroughly. Now the third point, when we look at the nearby object, ciliary muscles contract. Opposite to second point. Ciliary muscles contract, eye lens becomes thick and focal length decreases. And with the help of these all, we can see the objects present on nearby distance clearly. So this was the answer for question B. Now we will see our question, and the question is, star appears to twinkle, but the planet do not twinkle. Why? So stars appears to twinkle because their light passes through different layers of Earth atmosphere, which bends light continuously. So as we know, beside Earth there is an atmosphere. In atmosphere we have different layers, and this light which is coming from the star, it will pass from those all the different layers of this Earth. If here I will draw this Earth, imagine if this is the Earth and these all are the layers of atmosphere present beside this Earth. And now if you draw star, now imagine somewhere here we have a star and this is the Earth surface. The person is standing on this Earth surface. Whatever light is coming from the star, it will come straight. When it enters into the Earth atmosphere, it starts bending like this due to refraction process. Then once it enters into the next atmosphere layer, again it bends. Next, again it bends. Next, again it bends. And the person standing here will see the star somewhere here. So the position of the star also will be different. Apparent position of the star also will be different. As well as because of this continuous refraction in the atmosphere, this star will appear like it is twinkling. So this is the reason. Now see the next point. Since stars are very far away, they look like tiny points of light. So this bending makes their brightness seems to change. So this is the answer for second question. Stars are present far from the Earth, and because of the far distance from the Earth, the light which is coming from the stars, it will refract or bend many of the times, and it appears to twinkle. As well as because of this large distance, the stars will appear like a point of light. But what about planets? Planets are much closer to the Earth and appear as small disks. Stars will appear as tiny points of light, but because planets are very close to the Earth, they appear like a small disk. And the bending of light from different parts of the planet cancel out. Here, because of the less distance between the planet and the Earth, whatever bending of light takes place from the light which is coming from these planets, all cancel out, and therefore planets do not appear to twinkle. So this is the reason, or this is the answer for this question. Now we'll move with the next. Now question number 10, which has A, B and C option. So we will see first A option. The A option is, what is solenoid? So we have to write down the definition. A solenoid is a long coil of insulated copper wire would closely in the shape of cylinder. So understand here, we are going to take a insulated copper wire and we are going to wound it closely to get a shape of cylinder. So it will be like this. So imagine if this is a straight insulated wire and if we coil it or wound it in the shape of cylinder, it will look like this. So it will take a shape of cylinder, and this is only called as solenoid. So in this solenoid, if we supply the electric current like this, as we know according to right hand thumb rule, once the current is flowing into the wire, if thumb is showing the direction of electric current, then the fingers wrapped around it will show the direction of magnetic field lines. Means at every point on this wire, magnetic field will develop. And these all the magnetic field which is developed in these lines will add together, and this whole solenoid will behave as a bar magnet. So remember this, because there are so many circles. You can see this is first round, this is second round. So at every point magnetic field will develop, and it all together it will become a bar magnet. So here when the electric current flows through the solenoid, it produces a magnetic field similar to that of bar magnet. One end of the solenoid acts like a north pole and the other end acts like a south pole. So as we all know, for every bar magnet or for all the magnet there will be two poles, south and north. So same like that, even for this solenoid there will be two poles, south pole and north pole, which we can identify with the help of compass. Now we'll move with B question. State Fleming's left hand rule. So there are two rules, left hand rule and right hand rule. Both the rules are very important. In this paper they have asked left hand rule. In another paper they may ask right hand rule. So you remember both the rules. Now we will start with the answer. Fleming's left hand rule states that if the thumb, forefinger and middle finger of the left hand are stretched mutually perpendicular to each other, then the forefinger shows the direction of magnetic field, the middle finger shows the direction of current, and the thumb shows the direction of force acting on the conductor. Very important. First what we have to do? We have to take left hand and left hand thumb, forefinger and middle finger. All we have to stretch such a way that there should be 90-degree angle between all the fingers. And if you have hold in such a way, then forefinger showing the direction of magnetic field. You have to hold your forefinger in the direction of magnetic field. Then the middle finger shows the direction of current, and always in such case thumb will show the direction of motion or the force acting on the conductor. Very important, Fleming's left hand thumb rule. Remember, practice. Now question C. What is the potential difference between live wire and neutral wire in domestic electric circuit in our country? So always remember, in India, the voltage which is supplied in a domestic electric current, or we can say the difference in live wire and neutral wire in domestic electric current, is always 220 volt. You maybe have seen in your NCERT book, whatever questions they have asked based on domestic electric current, they have given the voltage 220. So remember, the answer of this question is 220 volt in India. So now we will move with the next question. Now we'll start with section 5. Answer the following question, and this section carries 8 marks. So we will start with question number 11, which has A and B option. So we'll start with A. State Joule's law of heating and name 4 appliances which work on heating effect of electricity. So first we will state the law. Joule's law of heating states that heat produced in a conductor is directly proportional to square of the current, resistance of the conductor, and time for which current flows. So remember Joule's law of heating, where heat produced, that is H, is directly proportional to square of the current, that is I square, resistance of the conductor, that is R, and time for which the current flows, that is T. So H is equals to I square RT. This is nothing but Joule's law of heating. If you remember this formula, then also you can state this law very well. So this was the answer. Now it has been asked, we have to write 4 appliances. In our day-to-day life, there are many more applications where we are using Joule's law of heating, where we are supplying current and producing heat. The first one is electric heater, where if we supply the current, heat will be produced. Then electric iron. For ironing clothes, we are using electric iron. With the help of current, heat will be produced, and with the help of heat, the clothes will be made straight. Third, electric stove or cooker. So if you have seen electric stove, where with the help of current, we will be cooking the food. Then electric kettle. This also will be used, where electricity is used, heat produced, and the tea or the water will be boiled. So these are some of the appliances where Joule's law of heating will work. Now, question B. Give reason. In this, we have 2 questions. First one, that is, the tungsten is used most exclusively for filament of electric lamps. So in case of electric lamps, we are using tungsten wire. So the reason for this we have to give. Tungsten is used for the filament of electric lamps because it can get very hot without melting. So at high temperature also, tungsten wire will withstand. It will not melt. This is one reason. It does not evaporate easily. At that high temperature, it will not evaporate easily, and it conducts electricity well, so it gives light efficiently when it is heated. So whatever wire, tungsten wire, you maybe have seen bulbs like this. There will be like this bulbs, and here there will be one wire in the bulbs. So this wire is nothing but the inside wire, which you can see is nothing but a tungsten wire. This inside wire is nothing but the tungsten wire which is present in the bulbs. So this will get heated up, and at high temperature it starts glowing. At that high temperature it will not melt, it will not evaporate, but it will glow. And with the help of that glow we can see the light, and that is the reason why we are using tungsten in electric lamps. Second, copper and aluminum wires are usually employed for electricity transmission. Especially in electric circuits, copper and aluminum wires are used. Why? We have to give the reason. First, copper and aluminum wires are usually used for electric transmission because they are good conductors of electricity. So we have conductors, we have insulators, we have semiconductors. So in the conductors, these coppers and aluminiums will come. So these are good conductors of electricity. Copper is strong and durable. Aluminum is light, cheaper, making them suitable for carrying electricity over a long distance. And because of this, all the reason we are using copper and aluminium for electricity transmission. So I hope you understood these all the questions. These my all the explanation will help you in exam, and I hope your understanding it is helping for you people to understand these questions. So share my videos with your friends, and please consider subscribing my videos or my channel. I hope all my videos are helping you all people to prepare for exam. I am trying to give a clear and a simple explanation for each and every question. If you like my videos, share my all the videos with your friends, and please consider subscribing my channel. So now we'll move with the next question. So now we are going to start to solve our question again, which is having A and B option. So first we will see A option. State Ohm's law. List the factors on which the resistance of a conductor depends. So what is Ohm's law? It states that the current flowing through a conductor is directly proportional to the potential difference across its ends. So remember what the Ohm's law says, whatever current is flowing in a conductor is directly proportional to potential difference across its ends, provided the temperature remains constant. If you change the temperature, then the current and potential difference both will change. Therefore, for every temperature, for a particular temperature, whatever current is flowing in a conductor, it is directly proportional to potential difference. Then, mathematically, it is given as V is equals to IR. Here V is nothing but a voltage, that is potential difference. I is nothing but current, and R is a resistance, that is constant. So according to law, current means I flowing through a conductor is directly proportional to the potential difference, means V. To remove this proportionality sign, we are using constant, and that is called R. So the formula will be I is equals to RV, or V is equals to IR. Also we can write like this, both are same. What is this? When we will get this formula, if we see V is directly proportional to I, then the constant R can be taken. If you say I is directly proportional to V, then the constant R will be taken, and these are the formulas. So these both the formulas are same. This and this, both the formulas are same. Where V is voltage, I is current, and R is resistance. So this R, resistance of a conductor, depends on which factor it is asked in the question. So it is depend on length of the conductor. So whatever conductor in which you are going to pass the current, it is depend on the length of that conductor. Longer the conductor, higher the resistance. Remember this. If you increase the length of the conductor, resistance also increases. Then cross-sectional area of the conductor. Larger the area, lower the resistance. Material of the conductor. Different materials have different resistivity. We have insulator, we have conductors, we have semiconductors. So depending on the material, resistance changes. Then one more is temperature. Resistance usually increases with the temperature. So these are the factors on which resistance of a conductor depends. Now we will see B question. The potential difference between 2 points is 1 volt. Mention the meaning of this. if somebody is saying potential difference between 2 points is 1 volt, then the meaning of that we have to explain. The statement potential difference between the points is 1 volt means 1 joule of work is done to move 1 coulomb electric charge from one point to another point. Remember this. If you want to get the answer 1 volt, then the work done should be 1 joule and the electric charge which is passed, it should be 1 coulomb. Because we know the formula of potential difference. What is the formula of this potential difference? The formula I will use different color. So potential difference V is equals to work done divided by charge. So work done, I will write it first. Work done divided by charge. And here work done symbol is W, charge symbol is capital Q. So we will write Q and this is V. Now, according to this formula, if V you want as 1 volt, then work should be 1 joule. Charge should be 1 coulomb. So now we will see the last question of part A physics, that is question number 12, which is a numerical part. So it is again divided into A and B. On this page we will start with A. An object placed perpendicular to the principal axis of a convex lens of focal length 20 centimeter. If the distance of image is to be 60 centimeter, then at what distance the object is to be placed from the lens? So first you have to read all the given sentence carefully and try to understand the sum and see what all values have been given and write down those all the given values and also write down what you have to find out. Then you think which formula we can use and then substitute the values. So we will start one by one. So if you see this sum, what I have given here, we are using convex lens. For this convex lens, focal length is given, that is 20 centimeter, and they have said if the distance of image is to be 60 centimeter, means image distance is given, and what distance the object is to be placed, means at what distance object, means object distance we have to find out. So we will start solving. So write down answer. And as I told, first we have to write what is given to you. So what we all have, so given, write down. We have focal length. So we will also write it is for convex lens. So I'll write it here for convex lens. So for convex lens we have focal length. Focal length is how much? 20 centimeter. Remember the signs what you're going to take. For convex lens, focal length will be always positive. Then we have image distance. Image distance we will take V is equals to 60 centimeter. So now we will take 60 as positive and we will solve the sum. And then we will see the sign of U. U means object distance. Object will be always on the left side of the lens. And left side all the distance will be negative. So we should get our answer negative. So I will take V as 60, positive 60 centimeter. And then what we have to find out? U, object distance, question mark. Now we'll write the formula. So for formula I am using different color. So our lens formula is 1 by V minus 1 by U is equals to 1 by F. So this formula we are going to use it. So this is our formula. Write down formula properly. Now we know the formula, we will substitute the values. But before substituting the values, what we have to do? We have to find out U. So we have to rearrange this whole formula. So take 1 by U outside and shift this 1 by V on the other side. So the formula becomes 1 by U is equals to 1 by F and 1 by V it should be, and then it should be minus 1 by F. So 1 by F. So this is the formula. Now everything is done. Now substitute the values. So 1 by U will be as it is equals to 1 divided by V we have, V is 60. So write down 60 minus F also we have, it is 20. So write down 20. Now find out LCM of this 60 and 20. So therefore 1 by U is equals to, so you know the LCM, how to find out. So now the LCM of the 60 and 20 will be how much? 60. So I will write it 60. If you want, we will find out the LCM also. So write down 20 and here it is 60. So smallest prime number will be 2. So 2 tens are 20, 2 threes are 6, 2 zeros are 0. Then again 2 2 5s are 10, 2 1s are 2, 2 5s are 10. Now we will take 5, 5 1s are 5, 5 3s are 15. Now 3, this one is as it is, 3 1s are 3. So see the numbers, multiply these all. So LCM is equals to 2 into 2 into 5 into 3. So 2 into 2 will be, write it here, 4 into 5 into 3 will be 15, and 15 into 4 will be 60. So this is our LCM. So take 60, and now 60 ones are 60, 23s are 60. So 1 minus 3. So now if you see, 1 by u is equals to 1 minus 3 will be how much? Minus 2. Greater number sign. Then it will be 60. Divide these both. So 2 ones are 2, 2 threes are 6, 2 zeros are 0. Now what is will be our answer? I'll write it here. So answer will be 1 by u is equals to minus 1 by 30. But we want to solve for only u. So therefore u is equals to minus 30, and the unit is centimeter, because here focal length also is in 20 centimeter, and image distance also in centimeter. So write down the unit for object distance, 30 centimeter, and it is in minus. So object will be always on left hand side, and on left hand side of the lens, whatever distances we will measure, all will be in minus. So now we are getting here minus sign, means our answer is correct. So this is the answer for question B, A. Now we'll move with the next question. Question B. The object distance and image distance of a lens are minus 30 centimeter and minus 10 centimeter respectively. Decide the type of lens and nature of the image. See the sum. We have to read it very carefully. Object distance and image distance is given. Object is 30 centimeter. So object will be always on the left hand side. It will be negative. So it is correct. But the image distance is also in negative. So image is also going to form on the same side of the lens. This is the first hint we got by seeing these values and the signs. Now we have to find out the type of lens and nature of the image. And for this, we are going to use the concept called magnification. So write down answer. So this we are going to solve with the help of magnification formula. So answer here, first write down what is given. So given what we have object distance and image distance. Object distance, that is u, is equals to minus 30 centimeter. Image distance, that is v, is equals to minus 10 centimeter. So we wrote. Now we will find magnification. Now find magnification, that is m, small m. So what is the formula of magnification? Magnification formula we have in terms of object distance and image distance, as well as in terms of object height and image height. So now as we have the values of object distance and image distance, we will use this formula, that is m is equals to minus v divided by u. So this is our formula. Now substitute the values. So m is equals to, what is v? 10. So write down minus 10. What is u? 30. That is this. Now see, minus minus sign will get cancelled, and then 10 ones are 10, 10 threes are 30. So m is equals to 1 by 3. Now if you divide this 1 by 3, we will get answer in decimals, that is we are getting plus 0.33. How we got this answer 0.33? So 1, here we will write 3, we will take 0, therefore it will be a decimal point. So 3 threes are 9, 1, again 0, 3 threes are 9, and this will continue. So we will stop here. So our answer is 0.33. So write down 0.33. So this is the magnification. And we know that if the magnification value is positive and less than 1, so see our value is positive and it is in fraction, so it is less than 1, then the image formed, it will be always erect, virtual and diminished. And this will happen only if our lens is concave lens, and therefore the answer is the lens is concave and the nature of the image is erect, virtual and diminished. So here we have completed the answer of question B. I hope you understood all the numerical part, and I hope you will understand all this complete video physics, that is part A physics. If you like my videos, share my videos, and also please consider subscribing my channel. Thank you so much. Thank you.